Have you ever flipped a light switch and wondered how the light comes on instantly? It feels almost magical. One tiny movement and suddenly, your whole room is bathed in light. It's something we do every day but rarely stop to question. Most of us picture electricity as a river of energy racing through copper wires, flowing smoothly from one place to another, like water in a pipe. It's a comforting image, and it makes sense. After all, wires look like little highways for energy. It's a simple idea. Electricity zips through the wire from the power plant to your lamp, traveling across miles in the blink of an eye. This story is easy to believe, and it's what most of us learned in school. This story helps us understand circuits and why a complete loop is needed. It's the foundation of every science fair project and every basic lesson about how our gadgets work. But science always digs deeper, and the real story of electricity is far stranger. The truth is, what's really happening is much more complex and much more fascinating than the simple river analogy. The idea of electricity shooting through the middle of a wire is a myth, a simplification that hides a mind-bending reality. The real process is invisible, and it's happening all around us, not just inside the metal. The energy that powers your devices doesn't actually travel inside the metal wire. Instead, the wire is more like a guide, shaping where the energy goes. Instead, what really happens is a dance of invisible forces all around us. These forces move through the space outside the wire, creating fields that carry energy in ways we can't see with our eyes. We're about to peel back the layers of this common belief and see what scientists have discovered. The real story is hidden in the details, and it's more surprising than you might think. The real action isn't inside the wire, but in the invisible space around it. That's where the energy flows, quietly powering our world. This is where the energy for your world is actually moving. It's a hidden highway, running just out of sight, but always at work. It's a secret path hiding in plain sight, and understanding it will change how you see every electronic device. Once you know the truth, you'll never look at a power line the same way again. Science is our best tool for finding the truth. And the truth about electricity is truly shocking. It challenges what we thought we knew and opens up a whole new world of wonder. Get ready to have your mind blown, because the real story of electricity is about to change everything you thought you knew. Let's revisit the water pipe analogy. It's a classic way to picture how electricity works, but it's not quite the whole story. A thick wire can carry more current, just like a wide pipe carries more water. The comparison makes sense at first glance, and it's easy to imagine electricity as a kind of liquid flowing through wires. But the analogy falls apart when it comes to speed and how energy actually moves. When you turn on a faucet, the water was already in the pipe, just waiting to be released. The water itself travels from the pipe to your glass. But flip a light switch, and the light comes on instantly, even if the power plant is miles or even hundreds of miles away. The response is almost immediate. The electrons inside the wire move incredibly slowly, drifting along at a snail's pace, sometimes just millimeters per second. If energy depended on electrons traveling the whole distance from the power plant to your lamp, your light would take hours or even days to turn on. Clearly, something else is at work, something much faster and more mysterious. The electrons are more like dominoes. When you push the first, the effect travels instantly down the line, but each domino only moves a tiny bit. The signal to start moving travels at nearly the speed of light, while the electrons themselves just shuffle locally, barely budging from their spots. The energy arrives long before the electrons do, lighting up your home in a flash. So if the energy isn't inside the wire, where is it? What's really carrying the power to your devices? The answer: our universe is filled with invisible fields, stretching everywhere, even where you can't see them. Gravity is a field that keeps you on Earth. And just like that, electricity has its own field. The wire isn't a highway for energy, it's more like a guardrail, guiding the energy along its path. The real action, the high-speed energy transfer, happens in the space outside the wire, in the invisible fields that surround it. This was the big clue that led scientists to rethink everything they thought they knew about electricity. The secret of electricity lies not inside the wire, but in the fields around it, hidden in plain sight, shaping the world in ways we're only beginning to understand. Meet the true hero, the electric field, a force that quietly shapes the world around us every second of every day. An electric field is an invisible force that surrounds any charged object, whether it's a tiny electron or a massive power line. It's like an aura, pushing or pulling on other charges nearby, even if they never touch. In a circuit, A power source creates a voltage difference, making one end of the wire positive and the other negative, setting the stage for electricity to flow. This instantly sets up a powerful electric field in the space around the wire, reaching out into the air and even through walls. The field fills the room, strongest near the wire, and is established at nearly the speed of light, almost as if it appears everywhere at once. Imagine a stretched rubber sheet, push one end, and a wave travels instantly across, carrying energy from one place to another. The electric field works the same way. The energy moves, not the material, so nothing physical has to travel the whole distance. The wire shapes and creates this field, acting as a guide for the energy to flow where it's needed. The field pushes on electrons, causing current, but more importantly, it's where energy is stored and transported, like a hidden highway for power. Plug in your toaster, and you're tapping into this energy-filled field around the cord, drawing power from the space itself. The energy to toast your bread is pulled from that field, not from inside the wire, making the field the true source of the magic. The wire is just the tool that sets up the field, a silent architect shaping invisible energy. The real power is in the space around it, an unseen force that powers our world, waiting to be harnessed. The electric field doesn't work alone. It has a partner, the magnetic field. James Clerk Maxwell discovered that changing electric fields create magnetic fields, and vice versa. They're two sides of the same coin, always linked. When you flip a switch, you create an electric field, which pushes electrons and creates a current. Moving charges generate a magnetic field that wraps around the wire. Place a compass near a current-carrying wire, and you'll see the magnetic field in action. Now, around every wire, there's an electric field stretching between wires and a magnetic field circling the wire. Both fields store energy, pulsing and interacting, strongest near the wire's surface. This combination is called an electromagnetic field. Light, radio waves, microwaves. They're all electromagnetic waves. The energy powering your lamp is the same kind of energy as sunlight, just at a much lower frequency. Electricity is electromagnetic energy, moving through fields. Here's the secret path of electricity. When you turn on a device, the power source creates electric and magnetic fields around the wires. These fields work together to carry energy, not inside the wire, but in the space outside it. Physicist John Henry Poynting showed that energy flows wherever electric and magnetic fields exist together. This flow, called the Poynting vector, points in the direction energy moves, parallel to the wires from source to device. The energy travels like a wave, guided by the wires, through the electromagnetic field. The wires are like people doing the wave in a stadium. The energy moves. But the people, electrons, barely shift. The energy that powers your lamp streams in from the space around the cord. Wires aren't pipes full of energy. They're antennas guiding electromagnetic waves. The real power takes the scenic route, through the air and insulation. If energy isn't traveling inside the wire, what's the wire for? The wire's job is to guide electromagnetic energy, not contain it. It sets boundaries for the field, telling energy where to go. Without wires, energy would radiate everywhere, inefficient and uncontrolled. Think of wires as riverbanks guiding water. The energy flows in the channel created by the wire. The metal conductor lets electrons move, shaping the magnetic field. The voltage difference creates the electric field. The insulation, dielectric, stores energy in the electric field, helping the wave travel efficiently. The wire is a director, not a container, guiding energy along its path. It's a subtle but profound shift in how we see electricity. Once you understand energy travels through electromagnetic fields, wireless technology makes sense. Radio, Wi-Fi, and wireless charging all use electromagnetic fields, just without wires. A radio station's antenna creates electromagnetic waves that radiate outward. Your car's antenna catches a bit of this wave, turning it into sound. Wireless charging pads create pulsing fields. Your phone's coil picks up the energy and charges the battery. Microwaves use electromagnetic waves to heat food by vibrating water molecules. In all these cases, energy is delivered through invisible fields, not physical connections. The secret path is everywhere, powering our world. Understanding this changes how we see everyday technology. You might wonder if this really matters. Your lights still work, right? For most people, the old model is fine. But for engineers and scientists, knowing energy travels in fields around wires is crucial. Designing computer chips, Wi-Fi, and antennas all depend on understanding and controlling these fields. At high speeds, fields can leak and interfere, causing errors, so engineers must sculpt the invisible fields precisely. This knowledge is key for high-frequency communication and efficient energy transfer. It's not just about gadgets, it's about understanding the universe. Realizing we're surrounded by invisible fields connects the electricity in our walls to the light from the stars. The world is more complex and interconnected than it seems. This deeper understanding expands our sense of wonder. Next time you flip a switch, picture an invisible wave of energy surfing along the outside of the cord at light speed. It flows through insulation and air, guided by copper, pouring into your device from the space around the plug. This weirder, wilder reality opens up new possibilities. Imagine homes bathed in safe, wireless energy. No cords, just seamless power. This isn't science fiction, it's the next step in mastering electricity's secret path. Science moves from simple myths to deeper truths, and electricity's story is a perfect example. We've gone from thinking of it as a fluid to particles to a dance of invisible fields. Who knows what future discoveries await? Stay curious, ask questions, and never settle for simple answers. The energy that lights our world is the same as light and radio waves. It connects everything. Understanding that connection is the first step to a brighter, more amazing future.